So yeah, today the talk is about Python website is slow. Think again. Some introduction. So my name is Iskandar. As I said before, I'm actually from Jakarta, but currently I work in Japan for the past 4 years. And this is my second PyCon in Indonesia. So I've been here as a speaker too in PyCon 2017, the first one, and I've been to several other PyCons around the world. At the time, I give a talk about deep learning, and this time I will give talk about a website performance. So if you are interested, you can check it out. There's a repository called a transfer learning and anime where I applied a deep learning to an anime project. So a bit introduction about the company. Currently, my company in Japan, we are selling a B2B cloud security enterprise to our customers. So if you think about it, our product name is called Henge One. We are providing such as access control to our customers. So some of these companies' name. This is a list of our customers. So let's go to the main talk. Who trusts Python in the world? Python users, like one of the biggest Python users in the world is Instagram. Instagram has like around 400 million users, and they have migrated from Python 2 to Python 3. So I'm wondering like how many people here are still using Python 2? Are there like any people here are still using Python 2? Everyone have moved to Python 3? Okay. So the other companies that use Python is like Quora, Reddit, Spotify, Dropbox, of course. It's where Guido works, and many others big companies. So Python is slow. We often heard a complaint that say Python is slow. Like there's some people like says the slowest thing on earth. One of them is Python. And Python is slow because of like one of the reasons is probably because it's in an interpreted language. So if you compare it to let's say C++ or Go or other compiled language, the performance is probably slower. And Python also has a problem with its global interpreter lock, or famous as GL. And if you compare Python to the other libraries, for example, you can see like Tornado probably only perform like 2,000 requests per second, but if you compare it to let's say Go, it can 50K requests per second and so on. So yeah, from this graph, we can know like Python is probably slow. But here is the catch. In most cases, the previous benchmark that you can see before, you get these numbers, right? But the main problem is most of the times, your server cannot handle those number of requests per second. Your server probably can only handle, like say, 20 requests per second per Docker container. And is it actually a bad number? Now, if you think about it, like 20 requests per second per container, let's say if one instance has a 4 CPU cores and you run a 4 Docker instances in your production, you have 40 Docker containers, it means you can serve 800 requests per second. So in 1 hour, you 2 to 3 million requests in 1 hour. So the number is not actually quite 3 million requests per hour for a website. So here the catch, like for web development, micro benchmark is usually not useful because micro benchmark, like the number that you see, so let's see, from the user perspective, let's say for one authentication request to our server, it takes 400 milliseconds. So if we break it down, we know that most of the times is actually spent to make a database calls because it tries to query to the database, it tries to retrieve a lot of records. And if you see to the details, like from the user perspective, 400 milliseconds per request actually contains of these breakdowns. Most of the times, half of the times is actually spent to make a database calls. And the other times is spent, let's say, to generate a summary response and other part of the code, where if you think like Tornado can serve 2,000 requests in 1 second, it means for this request, it only takes like 0.3 milliseconds, which is mainly negligible. So the catch is here. Like most of the waiting times is actually related to the IO bound operations. So website, especially if you are like not serving a machine learning stuff, mostly will have the bottleneck in the IO bound stuff. And let's take a look closer into the database queries that I said before. So one of the problems like we found is sometimes like this. So let's say you develop two different modules from different developer, but we don't know like what kind of database queries are used by each developers. In this case, we found that some of the queries are redundant, or we found that some of the queries can be optimized and can be combined together. So how can we solve this? We can use, for example, Python decorator to the rescue. Has anyone like familiar with decorators in Python? Anyone? Anyone? Decorators? Some people? Okay. So how do you use a decorators in Python is, for example, you define a call counter at the top left. This call counter will track how many database calls that you made and like how long each database calls is like requested being made. So for example, a get item there has a decorator call counter at the top. And let's say we call a get item operation twice and it will print something like this at the right side. So we know, oh, we make two database calls and we know we try to retrieve a user table and we try to retrieve a domain table. So with these decorators, we actually solve the problem where we can track for each request to each endpoint, like we know these queries are being made. And we can pinpoint, oh, probably we need to optimize this query and this query to make our website search faster. And there's also a catch about async IO. Has anyone ever tried async IO before? Oh, sorry. So async IO is first introduced in Python 3.4. It's a asynchronous HTTP client server, which is it's a module which is developed by native. Basically, it's included in the native Python since 3.4. And there's also AIO HTTP, which is a asynchronous HTTP client server for async IO. Okay, so has anyone ever used Tornado or Scenic framework for web development? No? Okay, so async IO here is nice because let's say if you run a multiple processes of Python. So for example, if you run multiple processes of Python, the bottleneck is usually the CPU level context switching. But let's say if you use multi-threading in Python, usually it will not end well because of the GIL and threading itself in Python is not that good. So the recommendation is to use async IO. But there are some common pitfalls about async IO that keywords, the async and await keywords doesn't mean it makes your application becomes an async application, asynchronous application. So let's say we have a code that looks like this. Let's say there's a long operation function over there, which is in the actual word, there's probably some application that tries to make a. Wait a minute. Okay, let's go back to the talk. So in this case, we're probably expecting if you run these functions that the first result should first, then the second and third. Over there. But instead, if you run the code at the left side, you will get the result that looks like this. You will see first, and then you need to wait for 3 seconds before you see third and second. So this is actually the most problems when people try to migrate from their old code to an async IO. They forgot that some parts of their code is still IO bound. If you don't change the IO bound parts into like async IO compatible, you will find these kinds of problems, and it doesn't actually speed up your website. So to solve these problems, actually when we migrated from Python, okay. Sorry for waiting. Hopefully it will not happen again. So to solve this problem, initially when we try to migrate from our old code base to SNIO compatible code base, we need to develop some libraries, some wrappers to solve the problem. So if you are interested, you can check our repository out over there. We created an asynchronous for Apple push notification service. We also create an async web driver, which is similar to Selenium, if you know. This is particularly helpful to test our program. And now, if you wrap the code like the IO bound code over there with the SNIO compatible code, then you will see the actual result as expected, that it happens like first and second will be printed, and the one that we put inside the SNIO ensure feature will run after 3 seconds and print third. And to improve your web performance, that's also about the third-party application or dependency that you use. So internally, we utilize a lot of AWS services. So we use Botocore in our application. So there's a tale of Botocore where suddenly one of our deployment caused like a jump from 200 milliseconds to 500 milliseconds. And when we track it down, apparently like the Botocore, the AWS SDK for Python, it utilized some low-level interface, and we try to search where the problem is, and we realized that the problem is about this, that someone reported that if you don't specify the region on the library, the library itself will make a round-trip request to solve the region and so on. So what I want to say here is this, that we need to do a performance test and upgrade often. Why? Because once the problem happens, and if you rarely upgrade your dependency, then it will be very hard to track where the problem is. So one of the recommendations here is to do a regular performance test, so you can keep track of the website average response time, the website CPU usage, and memory usage, and so on. And how do you test it? Internally in our services, we utilize these tools. Basically, we use PyTest with the driver that we made before with Circle CI to run the unit test, and we do a lot of integration tests with browser stack for mobile application mainly, and we also do Catalan tests and Apache JMeter tests for our website. And yeah, if you are still using Python 2, it's a reminder that Python 2 end of life is January 1st, 2020. So if you haven't migrated, please migrate it now. And Python 3 performance is actually 30% faster than Python 2. So this is the graph from our monitoring system. When we migrate from Python 2.7 to Python 3.6, the 50% average number of requests looks like this. So Python 3 is more stable compared to Python 2, and it also becomes faster by around 30%. And this is the CPU usage after we migrate from Python 2 to Python 3. As you can see, the peak also goes down to the graph at the right side. And if you see the graph over here, it looks very interesting because we are serving access control. And people usually log in the morning when they go to the work at 9 a.m. So the peak over there, you see, is probably 9 a.m. And since the session is usually expired after 8 hours, you can see some other peak after 8 hours in the evening. So the graph looks like this, looks like a mountain. And once you do the migration, please keep in mind that Python 3.7 and the latest comes with a lot of new features. For example, supporting like type hints, and they also support data class. Have anyone used these features before? Type hint and data class in Python? No? Okay, so this is actually a Python code. While it doesn't look like a Python code, this is actually a valid Python code. So as you can see, from data classes, we import a data class, and from typing, we can import like any kind of types that we use in the code. So if we define there, like say, this class, this is a user class with the data class of frozen is true, which means when you create a user object, it becomes an immutable object. What does it mean? It's that you can change the attribute once you create the object. This is particularly useful for some records that you want, let's say, you know that these parts of website should serve a read-only data. You don't want anything to accidentally write your record back to the DB. So in this case, you can use this immutable class, and if, for example, if you try to write it with something else, it will throw an error, which is what we expect. And you can also use type hint. For example, from DB function over there, you can say data is a dictionary that contains a string, and it can be, let's say, an empty value. So there's like a dictionary of string and any over there, and this from DB function will return a user class object. So once you do the migration, it's like very recommended that you write these things up. You use the type hinting, you use the data class to make your migration easier and to make your code is easily like readable by other people. And this is not really related to Python, but we also do a lot of infrastructure optimization. This is how our infrastructure looks like. We basically utilize ALB, ECS, and DynamoDB over there. And if you are using AWS, it's recommended to use a mixed auto-scaling with spot instances, since it's actually far more cheaper than reserved instances. And you can also do track unused stuff and set some retention periods to things that you usually use. For example, let's say the load balancer that you not use anymore, or the CloudWatch logs, you set the expiration for, let's say, 1 year and so on. It actually saves you a lot of money. And there's also a lot of various improvement that we continuously do. For example, when we need to cache some hot data, we put it inside Redis. And for example, when we need to improve some CPU bound logic, then you need to get a better algorithm to solve it. And let's say if you are low in memory, you can use a generator inside of for loops, and you can utilize memory profiler or PDB in pointing bottlenecks and so on. And there's also, why don't you go serverless? So the argument here that we are still using a server with ALB and ECS is because it's easier to maintain. We decided that serverless is actually harder to maintain because of the wiring between the DevOps toolings. And because we are utilizing a lot of security modules, let's say OpenSSL and cryptography stuffs in Python. So once we go serverless, we cannot really control the version, which is a problem. I mean, we can control the version, but it means we need to build it by ourselves, and it also takes another effort. And why don't you use another language, such as Go? Because Go is like quite famous, and we also use Go internally for some parts of our project. The argument here is because Python, there's a research about this that they said Python is actually one of the easiest language to learn, and you can develop software with Python, like one of the fastest one. So we decided to use Python for let's say, website application, but we internally still use Go for something that requires a high-speed performance, such as sending mails to the client. So yeah, the catch here is optimized for the user experience, and the cost savings will actually come by itself. So this is what we achieve after we finish the migration. We can cut the average response time from our website from 400 milliseconds to 150 milliseconds. And we also cut our cost from around $250K to $100K, which is around 60% savings. And by the end of 2018, this number can serve around 4 million users in 5,000 companies. And yeah, this is some results that you can see from our monitoring system. It actually really goes down after we do a lot of things that I mentioned before. So does it worth the effort? There's an argument that it's probably not worth the effort because sometimes the cost that you pay for the maintainer is actually more expensive than the cost of the system itself. But the catch here is if you can give a better experience to your user, they will probably stay with you longer. And you can, if you have a good coding style in your code, you can start developing a new feature easier, which means you can decrease your time to market. And it means you can have better user experience, and you can have faster rate of time to market. So this is the quote that I like, that it says, any improvement made except the bottleneck are an illusion. So this means it doesn't matter what Python framework that you choose. Most of the framework are probably performs the same as a performance because it's usually not the main bottleneck. What matters is actually your code base, how you write your code, how easy it is to add like a new feature to your code, and how easy it is, let's say, to maintain your code. Those are the main things that are most important. Like some people try to debate, oh, probably we should use this because this is better than that. But most of the times, that's not the problem. The problem is your coding culture, how you test your software, how you maintain the software. So the conclusion here is like for most web application, the slowness of Python is mostly negligible because it's usually not the bottleneck. The bottleneck is usually an IO-bound related operations. And a lot of popular websites can show that they use Python to develop Instagram, they use Python to develop Quora, Reddit, and so on. However, if your web application really needs a CPU-bound computation, then you can use a lot of external, external offloading to see codes, because Python also supports running it together with C codes, with Python, for example. And yeah, if you are interested in joining our company, we are also recruiting. We are based in Shibuya, Tokyo, and you can check the details in the QR code over there. And this presentation slide, if you are interested, is also available in my website. You can get it there. Okay, thank you. That's all from me. Any question? Yeah, I'm just curious, like how many people here are actually doing web development in production? Oh, okay, there's still some numbers. So what are the others like doing? Are like students or machine learning? Okay, who are doing things related to machine learning and data science here? One. How many students are here? Students. Okay. Thank you. Any questions? GIL is actually still a problem. So if you, let's say, write a trading codes, they actually still try to utilize the same core, CPU core. So that's why the recommended way of solving GIL is not to use threading, but to use async IO instead. The way async IO works, it still uses one core, but it uses an even loop. So even loop works like this. It works like a queue. So you can imagine there's a queue of tasks inside. Like internally, async IO uses a queue. So in the queue of, like in this queue, it keeps tracks of anything that it needs to keep track. So once it basically just iterates through the queue, and once it's empty, it will give the callback to the one, like let's say you say like await async IO's code here. Basically this await just an identifier to put this job into the queue. So in this case, the even loop is actually just iterate around, like in one CPU core. In that way, it solves the threading problem that we have in Python. So the solution here is we don't need to use threading. We don't need to care about the GIL, but we can use async IO.
First, let me using bahasa, boleh? Oh, boleh ya. Gini Mas, ini saya juga tertarik dengan yang async IO tadi. Itu kayaknya async IO bukan yang baru ya Mas ya. Soalnya saya dulu tuh tahu async await itu dari Node malahan. Ya. Ini kalau yang di Python baru tahu juga. Soalnya kan kalau misalnya kita mau eksekusi dari program, itu biasanya tuh dari atas ke bawah, ya kan? Nah, entah di program apapun, bahkan Python pun juga seperti itu. Nah, yang jadi pertanyaan saya, kan nggak semua bahasa pemrograman itu bisa menggunakan async await, ya kan? Tapi sebagai alternatif dari async await, ada pengganti, nggak tahu pengganti atau bukan, tapi biasanya menggunakan yang namanya worker. Nah, yang ingin saya tanyakan, ada nggak sih perbedaannya antara assign await itu sama worker? Kalau worker kan dia makan yang makan lagi. Dia kan mengambil yang namanya resource, entah itu CPU-nya, entah itu apanya. Sedangkan resource yang dipakai oleh async await ini, itu apakah jauh berbeda ataukah sama seperti itu? Nah itu pertanyaan saya.
Oke, saya jawabnya pakai bahasa Indonesia aja. Jadi sedikit konsep dulu nih tentang async IO. Baca gak sih? Kayaknya aja deh. Yaudah, udah ngomongnya deh. Jadi async IO itu sendiri, kan itu sebenarnya implementasi details. Jadi kayak async sama await keywordnya itu sendiri di Python itu sebenarnya implementation details. Jadi kayak misalnya kalian mau tulis hal yang sama di Python sebelum 3.4 juga bisa. Cuma problemnya nulis sendiri itu susah karena kita harus nge-handle exception-nya, harus nge-handle corner case-nya. Contohnya di Python 2 sendiri udah ada tornado. Nah tornado itu sendiri sebenarnya konsepnya udah mirip sama async IO. Jadi yang bedanya dibanding worker sama async IO, kalau async IO tadi dia prinsipnya pakai yang namanya event loop. Jadi dia cuma bakal nge-run di core, dia satu thread, dan dia bakal nge-iterate di thread itu. Worker itu biasanya trading. Problemnya trading adalah dia context level switching-nya itu dikontrol sama OS level. Jadi dia agak level nih penjelasannya. Jadi kayak kalau async IO karena dia prinsipnya satu loop, satu event loop, context level switching-nya application. Kalau misal trading, dia di OS level. Jadi kalau misal kita memang benar-benar butuh performance yang sampai CPU bound, it's more recommended to use async IO because the context switching is on the application level. Dibanding worker yang pakai threads. But in most cases, like say website, it's usually negligible because the IO bound problems that I've explained it before.